Have you ever had a haircut that just didn't quite turn out right? Something was off. Maybe it was a little too short, a little too off. Maybe it looked all right until you really started examining it. Well, that's exactly what we're talking about now. We're talking about 3D printers and calibrating to filament and nozzles. I know, a little out there, but maybe if your stylist got her or his scissors calibrated, that haircut would have turned out better. You never know. So why do we do this? Why do we calibrate? Well, it's a lot like finding that perfect recipe. Finding the secret sauce in McDonald's. Delicious. Or the Chick-fil-A sauce. Also delicious. But it took time to get those recipes perfected, and in 3D printing, calibrating is perfecting that recipe. In the end, it will save you time and money and energy because you will literally spend less time printing your model because you'll only have to hopefully print it once. It'll be less energy. Literally, with your energy bill, it will be smaller because you'll only have to print that model once, and it'll be less effort and frustration because, again, hopefully you'll only need to print it once. And of course, it also saves filament. And we all know that we love to save filament because splicing filament can be a little bit of a pain in the butt. Although, thank you, Sunlu, for the awesome way that you can now splice filament in a rather consistent fashion. Video coming shortly. Unless you're watching this way in the future, then you can look up on one of these sides for that magical card. Hit that like button if you really love saving time, money, and energy on your 3D prints. All right, let's break down what I mean by a new filament. And I don't mean just a new color. Maybe you're used to printing in black and you went white. Maybe you went gray. Or, oh, we got crazy now. We got blue. I know. So what is a new filament? Well, by new filament, I mean either a new brand. Maybe you're used to using Creality. Or maybe you're used to using bamboo. Although, given recent current events, I don't know how many people will be using bamboo printers. Filament, who knows? Maybe you're using MakerBox or Hatchbox. I almost said Matchbox, but we don't have any Hot Wheels here. Maybe you're using a different type of filament that you haven't used before. Maybe you started out like me, just PLA, and then you branched out and dipped your toes into that warm PETG water. Or maybe you got scalded by that ASA water because printing ASA is a pain in the keister. But either way, those prints would have gone better for me and for you had I spent the time, effort, and slight little bit of resources on calibrating my machine specifically to those different filaments. By new filament, I also mean staying with the same brand, staying within the same broad type, but maybe you're going from regular standard PLA to PLA Plus. Maybe you're going to Hyper PLA because you're trying to get that faster print. Maybe you're just trying a different quality. You know, Creality does the Ender series, the CR series, the Hyper series. Maybe you're trying something different there. Each of those series will have slightly different requirements. Maybe you got a new nozzle as well. The settings for your 0.4 millimeter nozzle are going to be different from your 0.8, from your 0.6, 0.2, 1.0. Let's get crazy, why don't we? Absolutely crazy. So what calibration tests do I run? Well, I start out with the temperature tower because if it don't melt, the rest of the test, it won't matter. Or if it melts too much, the rest of the test won't matter. That's where I like to start, and that's kind of where the consensus is, where you need to start with your temperature tower. After that, we move on to the flow rate. How fast can it go? Kind of related to how liquidy it is, so your melting point, but still, it is going to be. Next, we move on to flow rate. This is like adjusting the strength of that coffee that you're drinking right now. Delicious, delicious coffee. Stronger, weaker, it all depends on what you like and what your printer likes to get it dialed in just right. After that, we move on to the pressure advance. This smooths out the corners and makes sure everything's right. Are you pushing that filament a little too hard given the nozzle size? Are you not pushing quite hard enough as we go through? I don't know. but we're going to find out through calibration. Are you noticing a theme here? We're talking calibration. After that, we'll do a quick retraction test. This really helps out with the stringing issues. If you have a lot of stringing issues and you've already dialed in your temperature and you've already dialed in your flow rate, retraction test might be for you. Now, I will admit, going back to the flow rate, pressure advance. Now, I will admit, going back to that pressure advance, you don't always need to do it. Generally, default is okay, but I have found through my testing that it can help with some of those finer details. And if you're looking for that little extra, chef's kiss, then you might need to look into that. You can also go into the max volumetric flow rate and vertical fine artifacts for those who are looking to push the boundaries of the speed of your printer while still getting good quality prints. That's kind of on the advanced side. We're not going to go into that too much. I don't think it really helps all that much when we're just going with a normal print. But if you're trying to push it and you're trying to get the fastest print possible with the best quality possible, that's something you want to look into. How do you run these tests? Well, with a temperature tower, you go ahead and in OrcaSlicer, go to your calibration, and you will go ahead and select temperature tower. I generally like to put in about 5 degrees Celsius hotter and colder than what is printed on the label on your spool. Now, if you were talking the standard PLA, you're going to go from 190 to about 220. I went to 225 just in case and went to 185 because you never know. There could be some differences there that might work, might not. And then what you're going to do is print that out. After it prints out, you'll look at it and go, all right, I think it looks best at this temperature. In my situation, we're going to look at this and we'll see the best adhesion, we'll see the least amount of stringing, the best overhangs, and just evaluate here to see how everything goes. And it looks like for me, 210 degrees Celsius at the 0.6 nozzle works the best. Now I run 220 at my 0.4 nozzle because I need things to be a little more liquidy and they actually work out a little bit better. After that, we're going to go with flow rate. Now flow rate, you end up with all these sweet little chips right here. They have numbers on them. They can be easy or hard to read depending on your nozzle. They were much easier to read on my 0.4 nozzle than my 0.6 nozzle, but I digress. You have a couple different options in OrcaSlicer. I chose the 2-pass system. There is the YOLO system. I tried the YOLO system. It did not work out that well. I didn't get any that I thought were looking all right. Now, I go to the 2-pass. The first pass, you will get chips from positive 20 to negative 20 at 5% increments. Now, what you're going to do is print that out at whatever your base setting is. It's probably at 0.98 because that's generally what is working the best. From there, you will go through and you will visually inspect each chip to see which one looks best. Now, positive 20, minus 20, don't even bother with those. Same thing with the positive and negative 15. Although they are good aspects to see what over and under extrusion really look like. Now, under extrusion, you can really see the lines of the filament. It's not good. On the over extrusion side, at the plus 20, you can see these ridges forming up between the lines because it's all being pushed together. In my specific situation, I think that 0 and the plus 5 both look the best. And in this case, if you're unsure, you want to go with the bigger number. So in case it was 0 and negative 5, you'd want to go with 0. You want to go with the smaller negative number, the bigger positive number, whichever that happens to be. In my case, it's 5. And then we're going to go ahead and we're going to put that into this equation here. That is whatever your beginning flow rate is, most likely 0.98. In parentheses, it's 100 plus whatever number you find best, whether that is a positive 5, negative 5, positive 10, negative 10, 0, whatever it is, do that math. So in this situation, it would be 105 for me, and then I times that times the 0.98. I get my number, and from there, I go ahead and divide that by 100, and I get my final number. That's pass 1. Pass 2 goes from 0 to -9, or I should say -9 to 0. Again, print those out. You'll look through them, see how they look. This is where the fine tuning comes in. This is why you want to go over, because instead of 5% jumps as before, you are on 1% jumps now. So if you overshot and, you're between 0 and 5, and the actual number is, a 1% above that, then you'll find it here by getting the -4. Just like this, you'll find whichever one looks best. In my case, I think 0 looks the best. And so I went ahead and nothing changed. My flow rate is still the same. Pressure advance. This one you don't necessarily need to do. Generally, default works the best. But I have found that using the line test, that I can get slightly better results. Now, I'm kind of splitting hairs here, because between the 0 and what I found to work for me, which is 0.014, there wasn't a huge difference, but it was just a little bit. So if you want to take the time to do pressure advance, now's your time to do it. Otherwise, skip ahead to the retraction test. Now, with this, I went with the line test built right in. Kind of hard to see, but don't worry. I have a picture up now where it's much easier. With pressure advance, this helps smooth out the corners by compensating for the filament lag. Like I said, I like to use the line method here. Think of this as drawing a perfect unbroken line. You're going to print the test pattern and adjust based on how things look. So you'll go through and look and find out which one is the smoothest line. You'll see here, as I go up, where there's this big old blob at the end of the line closer to where the numbers are. That doesn't look so great. And then as we go up much higher, you'll see the blobs at the beginning of the line and gaps at the end of the line. So you're trying to find which line looks the best. It's like drawing a straight line with a marker. Sometimes it skips and you have to adjust and get a smoother surface until you do. Next, we move on to the retraction test, and it looks like this. You've got two little towers here that you're able to check to see where the stringing starts and stops. You will have this set between 0 to 2 millimeters with 0.1 millimeter steps for direct drive. You'll have to look at the description here on screen. I will tell you what it is for your Bowden drives, and you're going to look for stringing. Each little ring that you see here is 1/10 of a millimeter, 0.1. You'll add 1, you'll count those up to see where the stringing stops, and then add 1 to that because that's how the base layer works. And you'll see here, I have found where my best results are. Ever had stringing issues? I mean, come on. We've all had stringing issues. Look at this Benchy before calibration. Look at this. Look at this thing. It's awful. There's strings everywhere. I want to know about your worst stringing problems. What'd you do to fix it? Was it a retraction test? Was it cleaning something? Hey, was it drying out your filament? I don't know. I don't know. We move on to the optional section here where I'm going to skip over this. Let me know if you want a video dedicated to the max volumetric flow rate or the vertical fine artifacts. I want to know. Let me know in the comments below. Is that something I should do? Is that something you want to learn about? Should I do a deep dive into each one? Should I keep it broad? It's up to you guys. Let me know in the comments below. On one last final note, I should talk about the different nozzles. I've mentioned this previously at the beginning, but here, again, we want to talk about nozzle size. As you change the size of your nozzle, some of your settings will need to change. A thicker nozzle, you might need a higher or lower temperature rate, depending on how it goes. If you're jumping from, say, a 0.2 millimeter nozzle opening to a 0.6, you'll probably end up going down in temperature. Now, there is more material, but because you don't have to get it quite so runny to get it through there, through the opening, because the opening is legitimately, literally 3 times the size, things will change there. With that, you might also not need as much pressure, so you need to adjust the pressure advance. Your retraction might be different just ever so slightly as well. These are things where you can do, where you spend the time to adjust per nozzle, per filament now, and again, save that little bit of time, save that little bit of energy as it goes on. Now, it might take you 10 minutes to do this, but would you rather spend 10, 15, 20 minutes calibrating for your filament that you're going to spend 12 hours printing, say, the Green Ranger's Power Ranger helmet? Or maybe 21 hours. I don't know. I think I would rather spend that, 10 minutes doing it rather than have multiple failed prints. I may or may not be speaking from experience. Hey, there is a video coming up about the Green Ranger helmet that I'm making from the original Mighty Morphin Power Rangers TV show, because that show was the best when I was a kid. Oh yeah, hashtag 90s kid. Today, we covered a lot of stuff. We covered the essentials, your temperature tower, your flow rates, your pressure advance, and your retraction. Follow this order and you will get better prints. Now, it may not be a massive difference, and it might be a bigger difference. You might have other things that you need to consider too. How stable is the surface you're printing on? How clean is the nozzle you're printing from? How clean is your build plate? All those things can factor into better prints. But just from the calibration side, if you follow this order, if you follow those steps, which are basically the same between all the different slicing software, I covered OrcaSlicer. That's what I use. That's what I find that I like the best. But there are a lot of other softwares that are very similar. I know OrcaSlicer is a derivative of PrusaSlicer, which is a different... There are a lot of derivatives, and they're all very similar. They might just have slightly different names, and they might be in slightly different locations. I really hope that this is something you enjoyed. Let me know down in the comments below. Don't forget to hit that like button. Don't forget to subscribe for more informational videos, and we can extrude more value from that YouTube algorithm there.